Hey, what's up, everybody? Welcome to session 4 on iOS concurrency. And in this session, we'll look at some killer features of Apple's two concurrency technologies, Grand Central Dispatch and Operation Queues. So these are highlights from my video course. So if you've already worked your way through that, I'll completely understand if you want to go and learn about animations from Caroline or about Git from Sam, because I'm certainly going to watch their sessions when the vault comes out. So if you stay, GCD and Operation Queues help keep your app's user interface responsive by running the slow tasks off the main queue. And they provide features that you're going to want to use with asynchronous APIs, like animations and networking. So you'll see in the demos how to wrap these in a dispatch group or an operation queue. Now, running tasks at the same time can cause problems, and you'll see how to make your data objects thread safe to avoid race conditions. And the standard way to do this is with dispatch barriers, so that's why we're starting with GCD. But first, let's have a quick review of some terminology. You can dispatch a task either synchronously or asynchronously onto either a serial or a concurrent queue. Synchronous versus asynchronous is about the source queue. A synchronous dispatch blocks the source queue until the task finishes, and asynchronous dispatch lets the source queue continue immediately. Serial versus concurrent is about the destination queue. A serial queue runs one task at a time, and any other tasks have to wait, whereas a concurrent queue can run more than one task at a time. Swift 3 syntax makes life so much easier. I'm one of those people who used to always have to go and copy and paste when I wanted to dispatch onto the main queue, but now it's much, much easier. There are 5 global queues, one for each quality of service level, ranging from high performance to high energy efficiency. And to get the main queue, it's just dispatch queue.main. And that's where you run your UI updates. You can also create private queues, and they're serial by default. If you want to get a concurrent queue, you just use attributes.concurrent. And you add tasks to a queue with async or sync, and you can put the task into a closure. So typically you're going to dispatch queue .global async. You're going to do something expensive that you want off your main thread, and then when you want to come back to update your UI, you dispatch queue main async and do whatever it is that you need to do. And this is the compulsory dog photograph. So multiple dogs showing that multi-threading can be tricky to get right. Okay. So concurrency problems are hard to debug because they're unpredictable, they don't run at the same time, in the same order for the same duration every time you run them, so they're intermittent problems. So priority inversion can happen when a high priority task can be preempted by a low priority task. For example, you've got a low priority task entered the queue, locks a resource. High priority task comes along, wants that resource, and has to wait. And that will slow down your app because this is a high priority task. Apple's solution is to promote low priority tasks when a high priority task enters the queue. And so the high priority task still has to wait, but the lower ones get to go faster and they release their resources sooner. A race condition arises when 2 threads access the same resource, and the end result depends on how the threads are scheduled. So if you're lucky, task A reads and writes the resource before task B reads and writes the same resource, and then everything is fine. But another time you run it, task B might read before task A writes, and then task B writes an incorrect final value. So Xcode's new thread sanitizer tool can detect race conditions, and we'll soon see how to make an object thread safe. The third potential problem is deadlock. And this happens when two tasks are waiting for each other to release a resource. Task A holds resource X, task B holds resource Y, and each task is waiting for the other resource. And so neither task can progress or finish. So GCD and operations will help you avoid priority inversion and to some extent race conditions, but you just have to keep your wits about you to detect and avoid deadlocks. So some general advice is to help prevent priority inversion, just use one quality of service level for any tasks that access a shared resource. And you can avoid race conditions by using a serial queue to restrict access to a shared resource. And you always have to be careful using synchronous dispatch because it blocks the current queue. And so if your task requires access to the current queue, then you're at will deadlock. So you should never call sync on the current queue because the task won't be able to run and it will never finish. And you should almost never call sync from the main queue. It will block the UI. The one exception is using sync to control access to an object's value. It's a very short critical task. Using sync to block the current queue while you're getting or setting the value will keep the value consistent. Thread-safe code can be safely called from multiple threads without causing a race condition. And the simplest solution is to use a serial queue to restrict access to the value. So only one task at a time can read or write it, but that's kind of restrictive. So if you can't afford to do that, then you can use dispatch barriers. So what happens with a dispatch barrier is you've got tasks that only read, they can be running concurrently. And then you have a task that changes the value and it gets into the queue and it comes in as a barrier task. So any task that's already in the queue finishes, but no other new tasks are allowed to come in. That's what the barrier task is doing. It's keeping new tasks from coming in. And then when all the current tasks have finished, then the barrier task runs as if it's in a serial queue, runs all by itself. And then when the barrier task finishes, you can go back to being a concurrent queue. And new tasks can come in. So we're going to see how to do that in the demo. Now the other cool GCD feature is the dispatch group. If you want to know when all the green tasks have finished, you add them to a dispatch group. And similarly you can do for the blue and the orange tasks. And then you can be notified when all the tasks in a group are completed. So this is a pretty cool feature, and you're probably going to want to include asynchronous function calls in your dispatch group. But asynchronous functions return immediately, and this dispatch group might think it's finished when it's still working. So you have to adapt it so the group knows when it's really finished, and that's the topic of the first exercise in Demo 1. So let's have a look. Let's see if this is actually working. All right. This is not quite what I should have set this up better. What's going on here? Right. All right. So this is your Ray Wenderlich set of folders. We're up here in 4, iOS concurrency, and we're in Demo 1. And we're in starter, and we need this playground. Now, before I really get into that, down here are the slides as well. Right. And then right at the bottom, of course, you already know that there's the PDF full of all of the tutorials and things. So this is Caroline's, actually. So let's see. That's mine. Okay, and this is Demo 1. Now these documents here are just there in case you get out of sync with me and you need to go through and copy and paste some code to catch up. So that's what that's there for. And by the way, if you use the table of contents view, then it's pretty easy to find stuff. Okay. Now where's my Xcode? Damn. Okay, that's our demo 1. Open. Okay, now there are several pages in this, so in case you ever need to find your way around more directly, you can open up the navigator and you can see that there's some pages in there as well. Okay, so we start on the first page. And the idea of the first part, this demo comes in 2 parts. The first part of the demo, we're going to extend the animate with duration method so that we can add it to a dispatch group. And if we do that, then we can run multiple animations, and then we can do something when all the animations finish. But first I want to show you how you might try and do this without dispatch groups. Okay, so these are the views we're going to use. So the first view is just a red square. It's going to be our background, our main view. And then we have a yellow, smaller square that's going to move around inside of the red square. And down here we have a label that's going to say all done. And we want that to appear after all the animations have finished. So initially, it's hidden. Okay, so here are some animations. So in 1 second, the box is going to move from the upper left corner of the main square down to the lower right corner. And after it's done that, it'll take 3 seconds to rotate through 45 degrees. At the same time, the main view is going to change color from red to blue, taking 5 seconds. So in its completion handler, I unhide the label. Okay, so this combination up here is going to take 4 seconds. The color change is going to take 5 seconds. So I figure, okay, I'll put the unhide label into its completion handler. Oh, who's that? Right. So if you've never looked at views in Playground before, it's really easy. You just set its live view equal to view, and then you open the assistant editor up here. Open the assistant editor. Make sure you're on timeline here. Okay, and then you cross your fingers. Because Xcode can be really, really strange. Sometimes I have to restart my Mac several times. Yeah. So anyway, see, there's a little play button right down here, and you click that. Okay, so that worked. Now, the reason that worked, of course, was because I picked the longest running animation to put the completion handler in. But suppose you wanted to switch that around and you wanted to do the color change in 3 seconds and the rotation in 5. You wanted a slower rotation. If you wanted to do it this way, you'd have to start moving the completion handlers around and making them nil. And if you had lots more animations, you'd have to sort of go through and do the arithmetic to figure out which one was longer. And that's really not very elegant. So this is a job for a dispatch group, right? So you can press the little stop. Actually, no, it's going to do it yourself. Just click through to the next page, step 1B, and that stops the other one. Okay, let's get a little bit of space here. Right, so here are the same views, and down below are the same animations, but in between, we need a dispatch group. So let's go ahead and say let animation group equal, and to get a dispatch group, there are no options. You just say dispatch group and the default initializer. So that's our dispatch group. And now we just want to wrap the animate with duration method to give it this group, dispatch group parameter in there. So the rest of it is exactly the same as the usual animate with duration method, and we've just tucked in this group parameter. So when you're wrapping a method somewhere, you just have to call the usual method. So I found that the easiest way to get the right completion is to type with duration, and it gets you the right thing. And so you just pass through the same parameters, so duration, and the animations are animations. And let me see. And that's going to need a completion handler. The completion handler gets a success object. And we just pass that on to the completion that came in through the usual call. And that's an optional. So completion success. And so that's the original animate with duration that's being wrapped in our new function. And now we just have to hook it up with the group. What we want to do is we want to tell the group when is this animate with duration starting and when is it really ending. And that's pretty easy, really. Just before you call the animate with duration, you tell the group you're entering. So you just tell the group.enter, and then when in the completion handler, you tell the group.leave. That's it. So now the group will know when we actually finish the animation, and when the animation finishes, it will tick it off its list of tasks, and when all the tasks are finished, then it can do something for you if you ask it. Okay, so now we just need to rearrange our animations so that they're added to the group. And so if you look back there, it's just that the group parameter comes in just before the completion parameter. So let's go down here, and just before the completion parameter, we'll put in group, and our animation group, the one that we created up above, and a comma. Okay, and then we can grab all of that, copy it, and paste it in before the other two completions. Okay. And you notice that this last completion handler still has that label as hidden equals false. I'll leave that there for a minute while we do the notify, because that's what we're going to put in the notify. All right, so when the group, all the tasks have finished, then you want it to do something. So here's our animation group dot notify. And when you run a notify method, it wants to know which queue it should do this on. And this is a view, so you want it to be the main queue. So it's dispatch queue, dispatch queue dot main. That's so much easier. And then you want the work item. The work item can be in a trailing closure. And it's that thing that we did in the completion handler of the longest animation. So that's label dot is hidden equals false. Okay, so we're unhiding the label. And now that we've got it in the notify, then we can take it away from this last completion handler and set that to nil. Go away. Okay, so just to recap, we have the same views. We have an animation group. We extended the animate with duration method so that we could add it to a group. And then we went ahead and put the group animation group parameter into all of the animate with duration calls down here. And then we set up the animation group to do something when all of the tasks are finished. And that thing is that it's going to unhide the label that says all done. And then we took away the completion handler there. And so we still set live view to view, and we still have our assistant editor open. And because it worked the first time, it will probably work this time. No? Not going to work? Oh dear. Is it working for you? Yes. Yeah. That's very frustrating. Usually if it works the first time, it'll work the second time. Oh, that's right. Maybe it needs to be up here. No, it's just not going to appear. Anyway, if it's working for you, go ahead and change those numbers, the 3 to a 5 and the 5 to a 3. And then run it again, and you'll see that it still works. It will, the all done message will only appear after all the animations have completed. Evil Xcode. All right. Let's continue on to thread safety. So this has also multiple pages. So the idea behind thread safety is you've got a class, and there's something there that's going to try and change values in the class, and you want to be able to access the objects of this class concurrently with several tasks running concurrently. And so any task that's going to change values, you want that to be a barrier task so that it stops new tasks from coming into the queue, and then it runs by itself, and when it finishes, then more tasks can come in and run concurrently. So this is our class. The class is person, and it has a first name and a last name, and it has a method called change name, which is going to change the first name and change the last name, and then it asks to see the name. The name variable just concatenates the first name and the last name. Now, this is an interesting method, change name. So if you go in here, and I think that's person. Yeah. So in the change name method, it's got a random delay before it changes the first name, and then a possibly longer random delay before it changes the last name. And this is structured to make sure that we get a race condition. It's basically giving plenty of time for there are going to be 5 concurrent tasks running, and it gives them plenty of time to interfere with each other. So that, you really want to see something right away. Okay, so that's what we're going to do. So that's the class, and let's go back up to step. No, that's the wrong one. Okay, so this is basically a very simple thing just to show you that it works. When we only call it once, it works. Oops, wrong one. Okay. Oh, and you can select the main editor to get rid of the assistant editor. All right. you running or what? Yeah, okay. So when we just ask to see the value in a playground, it appears over here in the sidebar, and you can see that Brian Biggles has appeared. So let's go and see what happens if we have a concurrent queue, and we're running 5 concurrent tasks, all trying to change the name. So as I said, we need a concurrent queue, so let's create one. So that worker queue equal dispatch queue. And we want the label, and the label is reverse URL, so com.raywenderlich, or put your own in, and .worker. Okay, now that by itself is a serial queue, and if you want it to be concurrent, you could say comma attributes dot concurrent, and that makes it a concurrent queue. Now I also want a dispatch group because when all 5 tasks have completed, I want to see what the final name is. So let's have a name change group, and that's just dispatch group, the default initializer. Right. So now we still have the name changing person, Allison Anderson. We have now 5 names, Charlie Cheesecake, Delia Dingle, all the way down to Gina Gregory, and those are deliberately set up so that we can tell at a glance whether we're getting the right names or not. Okay, so now in the for loop, down here in to do 2 or 3, in the for loop we have a little bit of sleep, and then we call change name, passing it the new first name and last name, and then we print out the current name of the name changing person. And these 3 statements, we want to put them in as a task to the worker queue. So we have worker queue dot async. Yeah, I'll do it that way. So, and then you just wrap the 3 lines as a task to the worker queue. Now that doesn't do anything special. We also want to add it to the group. So go back up next to the .async and add in the parameter group name change group. Syntax is so much nicer, isn't it? Okay. So that does what we want it to do. Now there are going to be 5 tasks being added to the worker queue asynchronously. At the same time, they're being added to the group. So when all 5 tasks are done, then we're going to get something, which is our notify method down here. So when everything is done, we want name change group to notify us. Now in a playground, the main queue doesn't work very well, so I'm not going to use that here. I'm going to use the dispatch queue .global, and don't want that. And then again, we'll put the work item in as a trailing closure. All I want to do here is print the final name. Print final name / open name changing person dot name. Missing a happy? Okay. And the other thing that we can do in a playground is tell it to finish. So playground page dot current dot finish execution. Okay. So just going back up here, we have a worker queue. We're going to put 5 tasks onto it concurrently. We have a name change group. All 5 tasks are added to that. When all 5 tasks are finished, then it's going to print the final name and finish execution. Okay. Yeah, okay. So let's see what happens. So if you run it, now because these are print statements, they appear in the debug area. And we got an Evershed, which is correct, but all the others are wrong. Okay, they've all been interfered with by the other tasks, sneaking in and changing one name or the other before they got a chance to print out their current name. So that's a race condition, right? Okay, so let's see how to fix it. Okay. So what we need to do is go back to our person class and modify it so it's thread safe. And to make it thread safe, as I said, we want to be able to put in, we want to make change name a barrier task. And a barrier task is something that comes into a queue and stops everything else from coming into the queue. So that means that our person, our thread safe person, has to have a queue, right? So let's give it a queue. We'll call it isolation queue. Isolation queue. And that looks very similar to the worker queue. So it'll be a dispatch queue with a label, and this time com.raywenderlick.isolation. And again, it's going to be a concurrent queue. Okay, the reason you want it to be a private queue is because you don't want to be messing up your system global queues with this kind of activity, because it does stop all new tasks from coming in, so you don't want to interfere with your system queues. And then you want it to be concurrent so that it can get lots of work done when there isn't a barrier task running. Okay, so that's our isolation queue, and we're going to use that to override the change name method. So override func change name, and so we want that to go onto the isolation queue asynchronously. And what goes in there is the super dot change name. And again, just pass through the parameters that came in, first name and last name. Okay, so that's not a barrier task, that's just dispatching asynchronously onto the isolation queue. Look how easy. Go back up to your async, add the parameter flags dot barrier, and voila, you have a barrier task. How easy is that? Okay. All right, the last thing I want to do is override the name variable, because there can be some sneaking in before you can get hold of the name variable. And so you need to call sync on the isolation queue in order to protect it, to synchronize access to it. So we'll do override var name, which is a string, and inside of that we return isolation queue dot sync this time, and inside of that we return super dot name. So just to remind you, what's happening is that 5 change name barrier tasks So that group of code that we had before, so this code down here, so this sleep, name changing person change name, and print, those three statements are going in as a single task onto the worker queue, and we've got 5 of those going. Whenever the change name task enters the queue, then it's a barrier task. Nothing else can enter until it's finished. Because of that, we know that it will finish all by itself. It will have a perfectly valid name when it's finished. Okay. But then after that comes the print current name of the name changing person.name, and that's running on the worker queue. It's now going to call synchronously onto the isolation queue, which basically stops everything on the worker queue until it comes back with a name. So nothing else in the worker queue, even if it's a change name, barrier task, or whatever, it stops. Can't do anything. It can't sneak in there and change the name. Okay? So everything should be safe. Now all we need to do is, here we're using a person, and we just need to change that to a thread-safe person. And I know that your document says Anna Adams, but that was just oversight. Leave it as Allison Anderson. Okay, that's it. So let's go ahead and run this. And it's perfect. Okay, so that's pretty good. Now, let me show you how to use the thread sanitizer. It's also really easy. Now, you can't run the thread sanitizer in the playground, so we have to have a project. The project doesn't do very much except repeat what we've done in here. So you can go ahead and close that. And let me go and find my thread sanitizer. Sorry? Oh, right. Why do we need the isolation queue to read the name? It's because otherwise, because the print statement is not a barrier task, it can be running concurrently with other things. And so something else could be sneaking in and changing stuff. And so we need to protect. It's a common design pattern, just to synchronize, to call sync whenever you're fetching, setting or fetching the values of an object that can be accessed by multiple threads. Okay. Mm-hmm. Oh, I was wondering what that was. Here we go. Sorry? Oh.
I have a question. Mm-hmm. So, what is the role of the sleep function in the for loop? Like, why do we put it there? Like, without that, will the thread conditions work?
I think, again, that's just to give all the tasks a chance to get in and interfere with each other.
Okay.
So just, yeah. Okay, so let's see. Where am I? Okay. Okay. So let me just show you quickly how to turn on your thread sanitizer because it takes a while to run. So all you need to do is go up here, make sure you're in a reasonable simulator, and you want to edit the scheme. And you want to be in the Run section on the Diagnostics tab. And you see here there's thread sanitizer. Easy as that. Sorry?
Could you repeat that, please?
Okay. You got the scheme part? So you're editing your scheme. Let's undo that and back up. Then So your edit scheme is here under where you choose your simulator. And it's this edit scheme thing here. Let's see if I can. Does that help? Okay, so it's just the edit scheme thing under where you go to run your thing. And that pops open this box. And you want to be, it usually is in the run. It's on that run tab already. And yours might be over here someplace. And you just need to get over to the diagnostics tab. And up here is a thread sanitizer. Let's see. Yeah. Okay. And if you want it to pause after each issue, you can check that box, but we're not going to do that today. Oops, come back. Okay, and then you just close it. And let me get it running, because it does take a little while. Alright. So here in the view controller, I just basically have the same code that we've been using in the playground. So initially there's a change name race, and that's just using the person class, and then change name safely, which is commented out, uses the thread safe person. And so here we can see what's going on. Okay, right at the very bottom, you can see it's printed out a couple of things that are not quite right. Oh, actually, Charlie Cheesecake. That's okay. Oh, all right. Anyway, but in the meantime, it has found all these issues. Okay, and up here, you can see it's got a little purple exclamation mark with some number. Your number might be different. It often gives a different number, usually at least 6. And if you click on that, then it opens up in your Issues Navigator. And they're all race conditions on change name, either the first name or the last name. And yeah, we knew that already. But Thread Sanitizer found all these for us. Okay, so if you want to fix it, we just comment out the change name race, and we uncomment change name safely, and run it again. And yes, it's perfect again. Okay, now the interesting thing is, it tells you Thread Sanitizer debugger support is active. So once you've got it running properly, you're not confused by all these error messages appearing in your debug console. Your debug console, has correct stuff in it. It's very good to have this reminder that you've got the Thread Sanitizer turned on, because it, adds time and size to your build. So you definitely want that reminder so you can go and turn it off. Okay, so just go back up here, you can stop it, and go back into your edit scheme and turn it off. Okay, because that's the only warning it's going to give you. If it's not finding issues, then you don't know that your Thread Sanitizer is on, except that it's told you. Okay, and that's the end of Demo 1. Are there any questions?
Can you split it? Can you bring the issue navigator again and just explain how would you tackle like one of those added sanitizer issues?
So the question was, let's break it again. Let's try. Oh, and also turn on the Thread Sanitizer. And make it break. So the question was, if we have all these issues, what do we do with the information that we've got issues? That's probably a case-by-case thing. This one, in this case, it comes in and it tells us, you click on an issue and it takes you, obviously, to the place where it's happening. And not sure, I think most of these are just on the first name. Oh, okay, this one's complaining about the last name. So this would tell you that you got potential race conditions, and they're all happening in the same method, and probably just a flag to you that you need to create a barrier task out of this, because it's making changes to your object. And yeah, this is possibly a simpler example than you might, but yeah, if you have a class and there's any method that's going to be changing values in the class, that's probably a flag already that you should make that a barrier task and just wrap it in an isolation queue like this. Okay, so that's the end of demo 1, and pretty sure that we don't have time for a break, so let's go straight into the second part. Okay, so the second part, we're going to learn about operation queues. The operation queue is just the COCO equivalent of a concurrent dispatch queue. Dispatch queues always run first in, first out. Operation queues let you set up dependencies between tasks, and that can change the order in which they run. So you add tasks to operation queues as operations. If you want to quickly create an operation, you can create a block operation. You can add more blocks before you start it. It's an object-oriented wrapper for the default global dispatch queue. And the reason it's there is in case you have an app that is using operation queues and you don't want to mess it up by calling dispatch queues, then you can use block operations to basically get straight to the default global dispatch queue. Normally, you subclass operation, and then you can create objects of this class, and the subclass can have input and output properties, and you can add helper functions. They're like a class, but you always override main to call the function that you're trying to run as an operation. Okay? So you can run an operation on its own, but most of the time the reason why you want to use operations is so that you can use operation queues. So you normally add them to that. And then you let the queue manage the ordering and the execution. And operation queue doesn't have any options. You just say use the default initializer. Like dispatch queue.main, there is an operation queue.main. And that's where you can run your UI updates. And you can add operations one at a time or an array of operations. In the lab, you're going to be creating 3 operations, and you want with dependencies between them, and so it's convenient to use the array form of add operations so that you can add them all at once. Right. Now, dependencies. Suppose your app has an operation that loads a file from a network and another one that decompresses a file into an image. And you can see there that the output of the data loader could feed directly into the decompressor, like that. And operation queues let you chain operations together exactly like that. So you feed the output from one operation into the next. You would specify that the decompressor has a dependency on the loader. And so the queue scheduler, the operation scheduler, knows that the decompressor operation is not ready until the loader has finished. This is the killer feature of operation queues. You can build complex dependency graphs and then let the operation queue handle everything for you. But, there's always a but, operation dependencies is somewhere you could create a deadlock. You have to be careful. You can create a dependency cycle that will prevent your operations from finishing. Now, it's perfectly valid to have an operation in one queue depending on an operation in another queue. And that makes it harder to spot cycles. You just have to draw the pictures. So, for example, here we have the top operation queue. You've got a nice sequence of dependencies, but the middle operation also depends on the middle operation in the bottom queue. That's perfectly fine. No problem so far. There's a problem. Okay? If the middle operation in the bottom queue depends on the last operation in the top queue, it's a cycle. And there's no way that can ever complete. And you've got deadlock. Okay, so you just have to draw the pictures and look for the cycles, and then somehow try to work around them. Okay, so now we get to asynchronous operations. Because operation queues and dependencies give you such nice control over your app's operations, you will want to use asynchronous APIs like URL session in your dependency graphs. An operation queue starts the dependent operation when the operation it was been waiting for finishes. But as we know, asynchronous functions return immediately, and so there has to be a way for the operation queue to know that it really has finished. And so the typical solution is to write an async operation subclass which manages its state and communicates with the operation superclass through KVO. Okay? It's a little bit of work, but you only need to do it once and then keep using your asynchronous operation subclass. Now, the Boolean properties for an operation are is ready, is executing, is cancelled, and is finished, and they represent the current state. And initially, they're all false, and at some point, is ready becomes true, usually because something it depends on has finished. When the operation is ready, then the queue calls start. If it's an async operation, it needs to set its state manually to executing, because there's nothing else there that's going to tell the operation scheduler that it's still executing. Because then the asynchronous task goes off and does something by itself. During the time that it's working, its state has to remain is executing. And when it finishes, then it has to come back and say is finished is true, is executing is false. So we can't do this directly because the operation state properties are read-only, but they are KVO compliant. And so we're going to be setting up async operation so that we trigger notifications, KVO notifications. And that's demo 2. So let me grab my okay. And if you open up demo 2, it says start work in sources async operation, not Swift. So that's over here. Open your navigator, and you'll see that there's sources and somewhere in here. Which one is it? Yeah. Okay. So in async operation.swift, it's just a skeleton. And it's got a top part here to handle the state. And then we're going to override all of the operations states down here. Now, the difference between an async operation state property, it's a singular, it's just one state property. It's going to have 3 cases. And the operations, the superclass operations state properties, there are 4 of them. There's one for each state. Okay? So, but we're only going to have one. So this state enumeration. So we need, first of all, to set up an enumeration. So we have public enum state, which is a string, type string, and it's going to have 3 cases. Ready, executing, and finished. So the operations state properties all have is in front of them, and I've dropped the is so that we can tell the difference between the async operation state and the operation state. They look different. But for KVO, we need to return a key path with the is that looks just like the operations state properties. So here we have a file private. Come on. What's wrong with you? Sorry? It's supposed to be in the enum. String. Keep going. Sometimes Xcode is like that. Yeah. It was just having a hissy fit. Okay. So file private var key path string return. So we put the is back on. And we grab the raw value, ready, executing, finished. Come on. But we need to capitalize it. Okay, and so that will give us back the operations state properties. Is ready, is executing, is finished. Okay. So we use this now to get our state property. And we're going to let it default to ready. And now to take care of the KVO notifications, we're going to use the will set and did set observers. So just start with the will set. And in there, we need to do the will change value for key things. And so the first one is the new value dot key path. Will change value for key. Okay, we're missing something here. Will change value for key, right? Yes, stop doing autocomplete, why don't you? And so we need it for the new value and we need it for the current state. So let's think about what's happening here. If we're moving from is executing to finished, our state is moving from executing to finished, then the new value.key path is finished, and the state.key path is executing. And we're notifying the operation scheduler about those two values. Okay? And then we need a similar one for did change value. What are you doing? So you just copy the will set things and just change will to did. And instead of new value, up here we want the old value. Okay. So that's what we need to do for the state. And then down here there's an extension where we're going to override is ready, is executing, and so forth. Okay, so we're going to override open var because we need to access this. So is ready is of type bool. Now this is the most complicated one because the readiness of our operation doesn't just depend on what we think as an async operation. The readiness of an operation is mainly determined by whether the things it depends on have finished. And that's managed by the superclass operation scheduler. And so we need to check, so we'll return super dot is ready. And also whether our current state, whether the async operation state is dot ready. Okay. And then we do similar things for the executing and finished. So we want to override open var is executing. Also a bool. And this one is easy. We just return whether or not state equals dot executing. Same thing for finished. Override open var is finished. Also a bool. And we return state equals dot finished. Right. Now I'm going to do one more, which we're not going to actually need for today. What's your problem? Alright, we'll just wait. I'm going to do one more. Override open var is asynchronous. Also a bool. And this is an asynchronous subclass, so we return true. Now the thing is, this asynchronous property is only used when you want to run your operation not in an operation queue, but standalone. And then the system needs to know whether it's asynchronous or not. Okay, anybody spot what's wrong here? No, just pretending. Okay. Alright, so those are the Boolean ones we have to do. Then we have to override two functions, start and cancel. Okay, and in start, all we care about is if the operation has been cancelled, we need to set the state to finished. So this is all about managing the state manually. If it's cancelled, we need to set the state to finished. If it's being started, we need to keep its state executing. Okay, so if is cancelled, state equals dot finished, and return. Now, how can it be cancelled without us knowing? It's very possible that the app will say operation queue, cancel all operations. So at the operation queue level, it's going to just cancel all its operations. So it's going to come down from there, and that will trigger this is cancelled situation. Okay. Otherwise, if it's not cancelled, then the normal role of start is to call main. Remember, you override main to define an operation, and so start's purpose is to call main. But because this is an async operation, we have to make sure that the state is executing. That's about it. Oh no, sorry, one more. You have to override the open func cancel. And the first thing we need to do here is call super cancel. Okay, so that the operation knows that it's being canceled, and we need to set state equal finished. Okay, that was a great deal of typing of a lot of code. So let's go back and have a look. So first of all, we declared a state enumeration with 3 cases, and we create the key path by gluing is to the raw value capitalized. And then we set up the KVO notifications for when the state is going to change to a new value and when the state has changed from an old value.
Why the old value is used instead of new value?
That's what it does, because it's changing to a new value, and it says will change value to new, and it did change value from old. It actually flags an error if you leave it as new at that point. Yeah, it's just the rather mysterious workings of KVO. Okay, and then we used our state to override the operation, the superclass operations. Is ready, is executing, is finished, and we override start. The main thing we're concerned about in here is to make sure that we know when the state is finished and we know when the state is executing. It has to be managed manually. Sorry? Well, because if we didn't do this, as far as the operation scheduler is concerned, the async function returns immediately, and it looks like it's finished. And so that's why we have to keep sort of override what it thinks, and keep telling that no, I'm still executing, and because you're telling it I'm executing, it's your responsibility to also say it when you're finished. And we'll see that on the next page, in fact. Okay, so then it says, now go to the playground page, which is up here. And we can close the navigator. So that was a lot of typing, a lot of code. It would be good to get a chance to check it, and also to see what the process is that you need to follow in order to use all of this infrastructure. So what we have here is a toy function, a toy operation, and it's a slow add, which takes 2 numbers and adds them together. It's slow because there's this sleep in here. And then I created an async version of slow add. It's asynchronous because it's got an operation queue that it gets put onto. So here's our pretend asynchronous function that we want to now wrap in an async operation. So we have a slow add operation. It has 2 inputs, left-hand side and right-hand side, and it has an output result. In its main, typically in a main, you just call the function that you want to run as an operation and pass through the inputs. It gets back an output, which you then store into the operations output. And there's a to-do here that we're going to come back to. Okay. So it's tortoises all the way down. We had operation. We subclassed it into an async operation. We subclassed async operation into a slow add operation. These are still very generic things. We need to instantiate the slow add operation by giving it specific inputs. Okay, so left-hand side 42, right-hand side 24, adds up to 66. So now we have a slow add operation, and we create an operation queue, very simple, and we add operations and it's an array containing only slow add op. Because this is a playground, I can say wait until finish true. If you're doing it in your own app, you want to be very careful because that blocks the current queue. Okay? But in a playground, it's pretty much the only way to get to where we want to be, which is I want to wait until the operation is finished, and then I want to show the result, and then I want to finish execution. So, so if this is going to work, I would expect to see 66 over here in the sidebar, and the run button should turn, the stop button should turn back into a run button down here. Let's see. So you can see it's doing something, but there's no 66, and this button is still running. Okay, and that is because we didn't tell it we were finished. So finish that, and then go back up to the to-do. This is in a closure, so you have to say self dot state equals dot finished. Okay, so it's the responsibility of the main function in its closure, after it's called the asynchronous function, in the closure, set the state to finished. Okay, and now if I run it again, 66. Okay, so that's just a lesson that we have to remember to put dot finished in. Okay, let's go look at a more realistic operation. This is an operation that's going to download an image from the internet. And all it needs is an image name, which is a string, and a completion handler to handle the image that comes back. And it's got an output image as well. Okay, let's open the navigator again, and I'll show you. It's down here in Network Simulator. So the method, the async method, is download image, takes a string and a completion handler, and it's basically a URL session data task. Okay? But because we're in a situation where we're not quite sure what our internet access is, it's actually a mock URL session, and all this code up here is creating the response in the data to create the session, and then when I call a data task on the session, it gives me back the response in the data that I fed to it. So that's why it's kind of pretend, but it still acts like a asynchronous function. So that's important. Now, while we're here, let me show you what's in resources. So there's some photographs in here of train stations and street lights and stuff like that. We're going to be using this one down here because it's pretty. And now go back to the image load operation page. Oops. Okay. So here's most of the image load operation. It's got the image name, the completion, the output image, and the initializer, and we just need to override the main function. And as I said before, all that is you want to call the method that you want to run as an operation. So that's download image named, and when we create the operation, we're going to pass in an image name. So that's what goes in here. That's the input image name, and then we're going to have a completion handler for this, and we'll just do that as a trailing closure. It expects to get an image, and the first thing you should do is save that into your output, self.output image equals image. And remember, really important thing for an asynchronous operation is to set its state, self.state equals dot finished. And then we pass it on to the completion handler that came in as the input. Self dot completion of image. Okay. What are you doing? Oh, right. You have to be careful about this autocomplete stuff. It's always trying to... That is actually correct. No. Image. It's always trying to stick the image name in there. Make sure you've got self.output image equals image, not image name. Okay. Alright, so that's our image load operation. And that's the image load operation class. And to use it, we need to create an instance of it. Let image load equal image load operation, and the image name is train underscore night dot jpg. And again, we're going to make the completion handler as a trailing closure. Come on, get over there. Completion handler is going to get back an image. So image in. Except all I really want to do, because this is a playground, all I'm going to do is print the message image loaded. In an app, you would probably want to dispatch asynchronously back onto the main queue so that you can display this image in an image view, or you might want to just add it to an array or something like that. But so you would do that. So I actually don't need that image. I can put underscore in up there. Okay, what's the matter with you? Should be all right. Okay, so that's our image load operation, and then we need an operation queue. And we're going to use the add operations. What are you doing? Image load in the array. Wait until finished. True. Right. And then after it's finished, then I want to have a look at that image. And yeah, then we just want the playground to finish. Am I missing a... Ah, yes, but it's higher than that. Because the indentation is wrong. Aha. Okay, so that was the main... Yeah. Okay. All right. Right. So all it's done over here, where I asked to see the image, it's given us the dimensions of an image. And there's a quick look button here, and there's another button that will show it in line. And you can select that. Too late?
We got a few more minutes, and then we have to do your conclusions.
Alrighty. Alright, it's supposed to grow. Anyway, so yeah, you can do that there. Okay? And so that's how you do that. And unfortunately, I think we're running out of time. But the lab is worth doing because it has a lot of details about how you set up the connection between your operations so that you can pass the output of one into the input of the other one. So are there any questions about what we've done so far?
Just in the async operation implementation, that is asynchronous. Is that necessary?
The is asynchronous property.
Yes.
The is asynchronous property is only used when you run the operation not in an operation queue, because when you run it in an operation queue, it's automatically run somewhere else. Whereas if you run an operation all by itself from the main queue, it will run on the main queue.
Okay.
And if it's asynchronous, you need to flag that so that the operation scheduler knows to move it off the main queue.
Okay.
But
So
it only you only need it if you're not running it in an operation queue.
In the implementation of our main function, do we have to set the state at the beginning of that to executing, or is that managed somewhere?
So if you remember when we did the async operation definition, we overrode start, and in there, when we call main, we set state to executing. So that's taken care of, and that's why we just have to make sure that we tell the scheduler that we're finished. Anything else? Okay. Back again. Right. Well, yes. As I said, it's really worth doing the lab at some point, and I will be in Bell after lunch across the hall, so if you want to come and talk about that then, that'll be fine. So let's go on to what we learned. So we started out with some terminology and some syntax, and had a quick look at potential concurrency problems and how to avoid them. And we had a fun thing going with UI view animate with duration. And we added those animations to a dispatch group so that when they were all finished, we could do something like show a message. And we also used the dispatch barrier to make the class thread safe. And we saw how to turn on Xcode's thread sanitizer, and it would find race conditions for us. In demo 2, we created an async operation class and implemented an image load operation and added it to the operation queue to run. And in the lab, if you get around to doing it, there are 2 image filter operations with dependencies between them, and they're going to chain the image load and then the tilt shift and then the vignette operation, feeding the output of one operation into the input of the next one. And there's a cute little protocol that you use to do that. So where to go from here? Well, as I said, this presentation is highlights from our 12-part video course starring me. And our website has a 2-part GCD tutorial. It was recently updated by Christine Abernathy, and it covers basics, thread safety with dispatch barriers, dispatch groups, asynchronous testing, and lots more. The final word on GCD and operations is Apple's Concurrency Programming Guide. And you can find me on Twitter as Mataharima. I'm happy to help with any questions you have during lunch, in a few minutes, or in the Bell Room after lunch, or in fact, anytime during the rest of RWDevCon. So I hope you enjoyed this session. Thanks for coming, and I'll see you around.